Okay, number one, sum of the digits of a two-digit counting number is 11. If the digits are reversed, the new number is 5 greater than 3 times the original number. What was the original number? So, if we have a two-digit number, tens place t, units digit u. The value of said number is 10t plus u. If we reverse the digits, we have u in the tens place, t in the units place. The value of this number is 10u plus t. As far as what they're referring to as the new number and the original number is the tu and the new number is ut. So if we first of all focus on the harder of the two equations, if the digits are reversed, the new number, that would be this, is 5 greater than, we always ignore greater than statements until the end. Of course the word is equals. It says 3 times the original number is this. So if I write the equation out for that, the new number, which is 10u plus t, is equals 3 times the original number, that'd be 3 times the original 10t plus u, and it says this is 5 greater than this, so plus 5 makes them equal. If I simplify and distribute and all this other stuff, I'm going to get 10u plus t is equal to 30t plus 3u plus 5. I'll move the 3u left and the 30t left, making both of them negative. Now let's move 7u minus 29t has to equal 5. Okay, the other equation is a lot simpler. The sum of the digits is 11. Here's the original number, add the digits equals 11. And since this is u first, t second, I'm going to write it that way here. So I'm going to put u plus t is equal to 11. So just like that, we got ourselves a system of equations. Elimination works. I typically would multiply by 29 because of opposite signs, but I think multiplying by negative 7 is easier here. I usually don't like to multiply by negatives if I can avoid it. I get minus 7u minus 7t is equal to minus 77. 7u minus 7u cancels. Negative 29 minus 7 is negative 36t. And negative 77 plus 5 is negative 72. Division gets me t is equal to 2. And I know the two numbers add up to 11, so 2 plus 9 is 11, so u is equal to 9. What was the original number is the request? Tens digit 2, units digit 9, so 29 is what we're looking for. Numbers 2 and 3 are both age problems, if I can get to it. There we go. The first thing to deal with age problems is if whatever the request is, that's which one of the variables to represent. So how old are they now? All right, so we want to put their ages now. So we'll say the man is currently m years old and the son is currently s years old. That's now. The next time period is, this doesn't say anything for this, so we can assume that's now. In 15 years, that's 15 years later. Alright, 15 years later, people age 1 year per year, so the man is currently m years old. In 15 years, he's going to be 15 years older, so m plus 15. The son's age currently is s years old. If we add 15 to that, we're going to get his age 15 years later. So we get their age then the other time period. And then whatever equation we're writing, we want to deal with the time period that involves that. So right now, at this moment in time, a man is 18 times as old as his son. That means the man's age is equal to the son's age. We'll start off there, which is false. Because we're dealing with them now, we're using the ages now. The man is 18 times as old as the son. Man's older, son's younger. The younger number, smaller number, gets multiplied by 18 to make the larger number. So m equals 18s is what we get out of that equation. In 15 years, so now we're doing the 15 years later, he, which is the man, will be 3 times as old as the son. Notice I use their ages for the 15 years later instead of the now, because it's this problem, this equation's in 15 years. He, the man, will be 3 times as old as the son. Again, man's older, son's younger. Younger, smaller number times the 3 makes the bigger number. If I distribute, I'm going to get m plus 15 is equal to 3s plus 45. So just like that, I got my system of equations. As far as a technique for solving this system, substitution probably work the easiest here. M is equal to 18s. Do a quick substitution there. Change m into 18s. I'm going to get 18s plus 15 is equal to 3s plus 45. Move the 3s to the left, move the 15 to the right. That gets me 15s is equal to 30. If I divide both sides by 15, I get s is equal to 2. So the son's age is 2 years old. The man is 18 times as old, so if I put a 2 right there, 18 times 2 is 36. So the man is 36 years old. Number 3, 20 years ago, Lucy was 2 years older than twice Myrna's age then. 6 years ago, Myrna was 3/4 as old as Lucy was then. How old is each person now? So 20 years ago, 6 years ago, but how old is each person now? So again, what they're asking me for establishes my variable setup. So I've got Lucy and Myrna. In the now time period, I'm going to say Lucy is L years old, Myrna's M years old. In the 20 years ago time period, that's in the past, so we take Lucy's age currently L, take 20 years away from it, that's how old she was 20 years ago. Myrna's age now is M, subtract 20, that's how old she was 20 years ago. And then it says 6 years ago, again in the past, so 6 years ago is what we're dealing with. Okay, again, going from their current age minus 6, so L minus 6 will be Lucy's age 6 years ago, Myrna's age M minus 6 is her age 6 years ago. So just like that, I've set up the ages right now, 20 years in the past, 6 years in the past. So as I'm writing the equations, I have to, again, be in the right time period when I write the equations. The first equation, 20 years ago. So that's this one. Lucy was 2 years older than twice Myrna's age then. So Lucy, 20 years ago, was 2 years older than. 2 years older than is just like saying 2 bigger than. So greater than, less than, we ignore. All right, so twice Myrna's age then. So 2 times Myrna's age then. Myrna's age then is being represented by more than one thing, so to multiply it times 2, I have to multiply the entire parentheses times 2. This is 2 greater than this, so plus 2 goes on the smaller side to make the bigger side. If I distribute, I get that. I'm going to move the 20 over to this side, so plus 20. That just gives me L equals 2M. Minus 40 plus 20 is minus 20 plus 2 is minus 18. So there's equation number 1. It's in good substituting structure. L equals everything else. I like that. I could have just easily gone L minus 2M equals negative 18. I'm going to go for substitution on this one though. 6 years ago, now we're dealing with this time period. So we're using these ages here. Myrna, which is M minus 6, was 3/4 as old as Lucy was then, L minus 6. Okay? Myrna was 3/4 the age of Lucy. So Myrna's younger, Lucy's older. We're multiplying by a fraction less than 1. Older person times fraction less than 1 makes younger age. If I distribute, I'm going to get M minus 6 equals 3/4 L minus 18/4. I could have reduced that, but I got to multiply by 4 to get rid of the fractions anyway, so it doesn't really help to reduce. It gives me 4M minus 24 equals 3L minus 18. So 4M minus 24 equals 3L minus 18. Okay, and just like that, I got myself a system of equations here that's going to help me solve the problem. Once again, I've got a substituting expression here. This expression, 2M minus 18, is equivalent to L, so I can do that substitution right there to get myself a workable problem. So 4M minus 24 equals 3, and I'm changing L into 2M minus 18. Replacing one object with multiple objects, so I put parentheses around the substitution. That's 3L, so I still got a minus 18 here. Distributive property gets me 4M minus 24 equals 6M minus 54 minus 18. I'm going to move the 4M to the right. This is negative 72, so I'll move it over as a positive 72. On the left-hand side, I've got negative 24 plus 72, which is 48. On the right-hand side, 6M minus 4M is 2M. Divide by 2, I get M is equal to 24. So M is Myrna's age now. The other age I need to find is Lucy's age. And I can go right here to find Lucy's age. I double Myrna's age, which would be 48. subtract 18, that should be Lucie's age. So again, 2 times 24 makes 48, minus 18 equals L, 48 minus 18 is 30 years old. Okay, number 4. Supposed to graph an absolute value inequality over a given domain. Domain's important, but not yet. So the first thing I want to focus on is the problem. I want to solve that. And this does say less than 2. It could just as easily say greater than 2 on the test. I know how to do both. But if you get an absolute value less than a positive number, the way we take that is the negative version of that number less than the contents of the absolute value bars less than the positive version of that number. So whatever this number is, negative that number less than the contents less than the positive. And then I want to get x in the middle, not x minus 3, so I got to do plus 3 to make that go away, which means I have to do plus 3 here and here. There are 3 locations, location 1, location 2, location 3. All 3 locations have to be modified the same way. Negative 2 plus 3 is 1. Negative 3 and 3 cancel, leaving me with x in the middle. 2 plus 3 is 5. So I'm graphing every number between 1 and 5. That's what this means. X is bigger than 1, x is less than 5, so between 1 and 5. Now here's where the domain matters. Domain is integers. I'm not including 1 or 5 because there's no equals. So if I want bigger than 1 and less than 5 at the same time, only integers, it's going to be 2, 3, and 4. So I'm going to shade in 2, 3, and 4 using closed circles. No open circles necessary in an integer domain. That's how you do it. And that's the answer. Now, just for instance, had the problem been this, absolute value of x minus 3 is greater than 2. We change this into x minus 3 is greater than 2, exactly what you see without the bars, or x minus 3 is less than negative 2. Flip the symbol, change the sign. Add 3, add 3. That gets me x is greater than 5 or x is less than 1. Greater than 5, not equal to 5, but integers would start here and go this way. Less than 1, not including 1, starts here and goes this way. So just be aware on the test. If it's a less than, it's going to look like the blue. If it's a greater than, it'll look like the green. In this one specifically, it is the blue, so the correct answer for this one is that. But again, if it's a greater than, it'll look more like the green. Number 5. Mary deposited $2,000 with 6% interest, or annual interest compounded continuously. How much money does she have at the end of 8 years? So compounded continuously is this formula right here. And the 3 things we have to identify are what P equals, what R equals, and what T equals. Those are these 3 numbers. E is the base of the natural logarithm. We have a button on our calculator for that. So P is how much money is invested, which is $2,000. R is the interest rate as a decimal. So 6% is 0.06. And again, be careful with single-digit percents. 6% is 0.06, not 0.6. Be careful, the 0 shows up. And T is the number of years. So 8 years. So once we know these 3 numbers, to get the answer, we simply are going to say that value of money at the end of 8 years is going to be what we invested times E caret parentheses, and then it's R, which is 0.06, times T, which is 8, in parentheses. So it's going to look just like that typed in my calculator. I'm going to calculate over here so we can see. So I'm going to type in 2,000, make sure I type all the zeros, times. To get e to the power, I hit second ln, and that brings up e caret parentheses. And then we type in the percent times the number of years, and then we type in parentheses equals, and it tells us how much money we have. So at the end of 8 years, we should in the account have $3,232.15. All right, number 6. How many different auto tags, also known as license plates, can be made by 3 letters followed by 3 numbers if no repetition is permitted? So first of all, if we're trying to figure out how many different anything is going to happen, figure out how we're going to create these things. So 3 letters followed by 3 numbers, that tells me 6 pieces. 1, 2, 3, 4, 5, 6. The first 3 pieces are letters. And the last three pieces are numbers. Digits, 0 through 9. All right, so letters in our alphabet, we have 26 letters. And in the decimal number system, we have 10 digits. So, it says O and 0 are both allowed, so we're not throwing out over 0 because they look the same. So, O's would be here, zeros would be there. Okay. The one thing I do notice on this that hasn't happened a lot of times in these problems, it says no repetitions permitted. Once I use A, I can't use it again. So I can do A, that would not be legal. I can go A, C, D, that's fine, or I can go A, Y, Z, whatever. But I can't write the same letter 3 times in a row. So, when I'm picking out the letters, I have 26 letters to choose from. Any one of those 26 letters can go in the first slot. Once that letter goes there, though, one of these letters disappears, so I only have 25 letters left over to go in the next slot. Once I've used these 2 letters, now there's only 24 letters left to go in the last slot. Moving on to my numbers, we start off with 10 digits. So any one of the 10 digits can go here. Once I use one of those digits, though, there's only 9 left. Once I use 2, there's only 8 left. So the no repetition creates this stepping down of numbers. Once we get how much in each location, multiply the numbers together to get the answer. I simply have to type in 26 times 25 times 24 times 10 times 9 times 8. And it comes out to 11,232,000. You can expect the repetition will be an option there, so I could go repetition is permitted, repetition is not permitted, so be careful of that. And again, it's going to be some layout of numbers and letters, so just make sure that you got the correct number of slots for each thing when you do that problem. Number 7, find x. We have 3 natural log of x equals negative 4.13. First thing I'm going to do is divide both sides by 3. That gets just ln of x all by itself is equal to whatever that is. Negative 4.13 divided by 3, 1.3767. And I didn't say negative, but it is negative. And ln of x equals that. Recall that ln is just log base e. So what I'm going to do here, since I do not know what x is, and x is the argument, anytime you're looking for the argument, log of unknown, you take the base of the logarithm to the power that the logarithm equals to get the answer. So I'm going to type the second ln key to get e to the power. I type in my power, negative 1.3767. Notice I never hit the power key because when I hit second ln, it automatically puts a power symbol there, so you don't have to do anything. So it's e to this power. If it said log instead of ln, this would be log base 10. Now I'm going to do 10 to that power. So again, I might throw log at you on this one, but you'll get what you get there. E to the negative 1.3767 comes out to 0.2524. If you want to make sure you're right, it's real simple. Here's the original problem here. If I type the left-hand side of the equation in, 3 ln of this number, it should equal that number. So if I try it out, 3 ln of 0.2524, negative 4.13022. It's not exactly, but it does round to negative 4.13. I rounded, so it's going to be not exact. Number 8. Find the pH of a solution when the concentration of hydrogen ions is 0.062 moles per liter. So they're telling me H plus, asking for pH, so this formula is going to be the one that's helpful to me. And the formula very clearly spells it out. It says pH, what we're looking for, equals minus log of H plus. And H plus is 0.062. So if you just put H plus in the formula, you're looking at exactly what you need to type in your calculator. So I'm getting my calculator out. It says log, there's no base listed, that's base 10. So minus key, negative right here, not this one but this one. Log, and then 0.062, end parentheses equals, we get a pH of 1.2. And typically pH is 1 decimal place. If you go a couple, I'm not going to count it wrong, but usually 1 decimal place is good for pH. Number 9, show that 0.02163 is a rational number by writing as a fraction of integers. So, first thing I want to do is leave a little space here. X equals the number, and I'm going to leave a gap here also, 0.02163 with the 163 repeating. Then, since 3 digits repeat, multiplication by 10 to the third power, better known as 1,000, on both sides. Multiplying by 1,000 on this side just makes 1,000x, because this was 1x. 1 times 1,000 is 1,000. Multiplying this side by 1,000 is moving the decimal point 3 spaces to the right, 1, 2, 3, so it's going to be 21.63. And then the digits 163 repeat, so 21.63, then we repeat 163. Put the bar there so all the repeating things line up. Okay, and again, required to multiply by the correct number here in order to get the decimals to line up in the right places. Once I get the problem set up structurally correctly, now I'm going to subtract the blue from the red. So subtract the original from the multiplied object. 1,000x minus 1x makes 999x. Over here, tenths, hundredths, and then the thousands, 10,000s, 100,000s place all line up with the same number. So subtract all the way to infinity, all the way to infinity, all the way to infinity, all those cancel. What's left is just this really basic subtraction of decimals. 21.63 minus 0.02 is 21.61. And if I divide both sides by 999, there's my answer. It's not a good fraction because I got a decimal there, so I'm going to go 0.00. Both top and bottom have 2 decimal places, so then I can remove the decimals, so I get 2,161 on top, 99,900 on the bottom. That's the correct answer for at least half credit. To get full credit, you do have to reduce the lowest term, so the next thing I do at this point, once I get my half credit answer, is I look to see, does this thing reduce? And all I have to do to reduce it is look at the numbers that aren't 0 there. 999, that's 9 times 111. 9 is 3 times 3. 111 is 3 times 37. And then we have 2 zeros, which is 10 times 10. Each 10 is 2 times 5, so we got 2 2s and 2 5s. So this right here is the prime factorization of 99,900. All we have to do is check each of these 4 individual numbers to see if they reduce the top. 2 doesn't go in because it's not even, so 2's are out. 5, it doesn't end in 0 or 5, so 5 is out. If I add the digits, 2 plus 1 is 3, plus 6 is 9, plus 1 is 10. 10 does not divide by 3, so the whole thing doesn't divide by 3. And I don't know about 37, so I just typed that one in. 2161 divided by 37 comes out to a decimal, so it doesn't reduce by 37 either. So I've tried everything, none of it reduces the bottom, or I should say the top, so it doesn't reduce at all. So that is actually the full credit answer. On the test, anticipate it reducing. I'm not saying it will, but it's a possibility it will reduce. And again, to get full credit, you have to reduce. If you want to make sure you're right also on these, it's really nice. All you do is type in 2161 divided by 99900. Type in your answer as a division problem. Top divided by bottom equals, and you should be staring at the exact same decimal number you started off with, 0.02, 163, 163, 16. So that it's really easy to verify the correctness of these. Number 10, solve negative 5x squared equals 2x minus 1. First thing I do is move the 5x squared to the right, so I get 0 equals 5x squared plus 2x minus 1. 5x squared moves, it became positive. 2x stayed positive. 1 stayed negative. Now, I'm not looking at this as a factoring problem. This would be one that I wouldn't be able to factor very quickly if it did factor, so I'd probably go straight to the quadratic formula here. As we hopefully recall, the quadratic formula structure is something plus or minus the square root of something over something. And as far as the somethings are concerned, b is positive 2, minus b goes there. So positive 2, change the sign. A is positive 5, 2a goes on the bottom, so that would be positive 10 on the bottom. And then b squared minus 4ac is the third object, that goes in here. I take whatever b is and square it. 2 squared is 4, minus 4 times a, which is 5, times c, which is negative 1. 4 is 4. 2 negatives make a positive. 4 times 5 times 1 is 20. 4 plus 20 is 24. That's the correct answer for half credit. Now, at this point, you're in Algebra 2. It's the last test of the year. You guys know how to reduce radicals. You know how to reduce fractions. To get full credit on this, I need you to reduce everything as much as possible. So, first off, the square root of 24. If I did a factor tree of 24, it's 4 times 6. 4 is 2 times 2. 6 is 2 times 3. Pair of 2's in, 1, 2 out, so 2 times the square root of 6 is the same as the square root of 24. So that's the first place I'd go. Negative 2 plus or minus 2 times the square root of 6 over 10. That's a better version of that. Now, this is still not finished because 2 and 2 and 10 are all even, so then I can reduce all three of those outside numbers by 2. I'm going to get -1 plus or minus the square root of 6 over 5. This is your full credit answer, that's your half credit answer, and I'd say that's half credit also. So I'm looking for a fully reduced, nicest answer possible to this problem. So that's what I'm looking for full credit. I would expect the same type of thing where it's going to be some thing you can factor out at least. If this was 2, 3, and 10, you're done there, but 2, 2, and 10 are all even, so you can reduce again. So reduce it as much as possible, give me the best answer possible for full credit. Have this on your paper in case you mess up, so you still get your half credit for having that right, but do try and get all the way there for full credit. Number 11, we got a fraction equation, a decimal equation. I'm going to take the top equation by 2, multiplied by 2 in order to get rid of the fraction. 3/2 times 2 is going to be 3, so I get 3x. 2 times y is 2y, and 2 times 13 is 26. Make sure all three numbers get multiplied by 2. On the bottom, we have 2 decimal places, 2 decimal places, and if I put a 0 there, 2 decimal places. That gets me 20x minus 2y is equal to 112. So, at this point, if I add the two equations together, 3x plus 20x is 23x. Positive and negative 2y cancel. 26 and 112 is 138. Divide both sides by 23, I get x equals 6. Once I know what x equals, I go back to one of the two equations. I like the blue one better. It says 3 times x plus 2 times y. We haven't found that. It equals 26, so it's 26. So 3x, x equals 6, so I just did 3 times 6 is 18. Everything else in the blue equation plus 2y equals 26 stayed the same. Move the 18 over, that gets me 2y is equal to 8. Divide by 2, I get y is equal to 4. And x equals 6 and y equals 4 are the correct answers for x and y. I do expect an ordered pair answer. So once again, looking at half credit, full credit. If you write x equals 6, y equals 4, I'll give you half credit. Write an ordered pair in correct order, you get the full credit for that answer. And do expect nice integer answers on that one. Number 12, we're adding vectors. So, what I notice is we have vector 1 is 4 and an angle of 20 degrees. So, I'm going to do 4 cosine 20 and 4 sine of 20. I probably, before I even type those in, I should have looked, but I'm going to look right now. It does say degrees. If you're not in the right mode, you hit the mode button. Make sure your degrees is highlighted. Just go down, hit over, so it's blinking on degrees, hit enter. At the top of your screen, it should say degrees. If you've got the TI-83 Plus instead of the TI-84 Plus, it won't have that at the top. Just hitting mode, you can see that whichever one's highlighted is what you have. But magnitude cosine gets you the I vector, so 3.76 I vector. I'll tell you what, I'm leaving off stuff right now. 3.76 I vector, and the 4 sine, the magnitude sine of the angle gets us the J vector, so it's going to be plus 1.37 J vector. So that gives me rectangular coordinates of the first vector. Second vector, -6 angle 230, so I do -6 cosine 230 and -6 sine of 230. Again, I get the I vector and J vector numbers, so I get positive 3.86 I, and I get positive 4.60 J. If I add them together, they're both positive, so I add, I get 2 carry the 1, 6 carry the 1, 7.62 I. And here, 7 plus 0 is 7, 3 plus 6 is 9, 1 plus 4 is 5, positive J. And again, both positive, so I added. If the signs are different, subtract. The bigger number determines the sign of the answer. This is, again, here's a half credit, full credit situation. If you get me right here, that's half credit. Okay, it's the correct answer, but it's in the rectangular form. I'm expecting to go back to polar form on these problems. To go back to polar form, it's a 3-step process. Step 1, R equals the square root of 7.62 squared plus 5.97 squared. Ignore any minuses, any negatives on this step, because when you square, you get positives anyway. So I type in square root 7.62 squared plus 5.97 squared, and I get 9.68. Step 2, alpha equals inverse tangent of the vertical over the horizontal. So 5.97 over 7.62. Again, this is an absolute value expression in the technique, so minuses don't matter. Again, there's only positives here anyway, but if there's a negative on the test, absolute value, so pretend everything's positive in this step. Inverse tangent, so second tan, make sure it says tan negative 1. 5.97 divided by 7.62 comes out to 38.08 degrees. Step 3 is the only place minuses matter. There's my 4 quadrants, 1, 2, 3, and 4. Positive horizontal is to the right, positive vertical is up. If I go right and up, that puts me squarely in the first quadrant. So in step 3, the first quadrant, the rule says that theta is equal to alpha. Alpha is, of course, 38.08. Had it been in the second quadrant, we do 180 minus, third quadrant 180 plus, fourth quadrant 360 minus. Once I get all 3 of these things figured out, the magnitude and theta are the 2 numbers I'm looking for. So I'm going to go 9.68 at an angle of 38.08 degrees. And again, that's my full credit answer. My half credit would be stopping here. If this is written on your paper and you mess up here and get the wrong answer here, I'll still give you the half credit for having the rectangular form right on your paper. So make sure you have that written down on your paper somewhere. Make sure the half credit's there. But again, sometimes people mess up, they get in the wrong quadrant, they maybe put a minus sign in somewhere they shouldn't. So that type of stuff happens. Make sure the rectangular answer, correct answer is on your paper. Nobody ever messes up on this usually. So at least have that written on your paper just in case something goes haywire in the change in the polar. Number 13, solve for x. We have logarithms being subtracted. The only requirement of logarithms, it doesn't matter what base they are, just as long as they're the same. So log base 4, log base 4, log base 4. Everything's base 4, so you can ignore the bases. They're not going to matter in this problem. All right. Go ahead and write it as you're writing it down, but just know that that 4 is not going to have any basis for how we're going to solve this. The rule says if I have log of anything base b subtracted by log of anything base b, as long as the bases are the same, which they are, the rule says that I'm going to get log of the first thing divided by the second thing base b. So that's the rule. That changes from a multiple log expression into a single log expression. So that's what I want to do to my left-hand side here. So I'm subtracting 2 logarithms. I want to create one logarithm, base 4, of the first argument divided by the second argument equals the other side. And if log equals log, which is where we're at right now, then argument 1 is equal to argument 2. So once the logs are equal with the same base, the arguments are equal. So that's the point where the 4's don't matter anymore. So x minus 3 over 7 has to equal 31. Now, I'm going to put the 31 over 1 just so it's a nice proportion. If I cross multiply this product, which is x minus 3 times 1, is equal to that product, which is 217. And if x minus 3 is equal to 217, now the logarithms are out, it's just a basic algebra problem. Move the 3, change the sign, combine like terms, 217 plus 3 is 220. And the only thing you have to do with check with logarithms, make sure they're actually legally the right answer, is make sure all the arguments, and again when I say argument, what are we taking log of? Log of x minus 3, log of 7, log of 31. So those 3 things have to be positive. So 220 minus 3 is positive 217, 7 is positive, 31 is positive. That's a fine answer. Okay? You don't have to verify that it actually works. You just have to make sure all the arguments are positive, and that's all that really matters as far as that answer. Number 14, once again a logarithm problem. Once again we have too many log expressions on the left-hand side. So the first thing I want to do, it's all base E. That's natural log, that's natural log, that's natural log. All my bases match up. I'm not going to throw anything weird at you on the test. They'll match up on the test too. But the rule says if I have log of anything base B added to log of anything else base B, I'm going to get log of the product of those 2 things base B. Once again, changing multiple log expressions into a single log expression. So what I have circled in black up here is going to become ln of this whole object times this whole object. This whole object here is in parentheses, so a distributive property is required. So 5 times x is 5x, 5 times 5 is plus 25. And that's going to equal log of 65. And once again, ln on the left equals ln on the right. If log equals log, then argument 1, 5x plus 25, is equal to argument 2, 65. Just like that, we go from a logarithmic equation into a basic algebra problem. Move the 25 over, 5x is on the left-hand side, 65 minus 25 is 40. Divide by 5, we get x equals 8. Again, all we have to do to verify the correctness of our answer is verify that all three of these arguments are positive with our answer. So, if I put 8 in for x, 8 plus 5 is positive 13. 5 is positive, 65 is positive, x equals 8 is a good answer. Final problem, factoring a difference of cubes. Okay, difference, subtraction, it could also be a sum of cubes plus. I wouldn't have a problem with putting a plus on the test, but it will be perfect cubes, perfect cubes. And power cubes just divide by 3 evenly. 3 times 2, 3 times 4, 3 times 1, 3 times 5. The bases have to be perfect cubes. 1, 8, 27, 64, 125, 216, 343, 512, 729, 1000. So that has to be a perfect cube, 2 times 2 times 2. But each of these just has to be divisible by 3, the powers. So the first thing I do is once I recognize it as a difference of cubes, which it is, I'm going to cube root each of these objects. So if I cube root this, the powers divide by 3. 6 divided by 3 is 2. 12 divided by 3 is 4. For the y and the z, 3 divided by 3 is 1. 15 divided by 3 is 5. For the minus 8, it's going to be minus 2. I didn't do 8 divided by 3, I did 2 times 2 is 4 times 2 is 8. So any base numbers, you have to find the number multiplied by itself 3 times to make that. But the powers, again, is just 1 times 3 is 3, 5 times 3 is 15, 4 times 3 is 12, 2 times 3 is 6. Once you get your first parentheses created, the second parentheses is simply created from the first parentheses in this way. Whatever this is, creates this by squaring. And squaring power expressions is you double powers. So m and p are what we're going to get. 2 times 2 is 4. 4 times 2 is 8. So if you have a letter to a power, you simply double the power to square it. To get this object here, we're going to multiply these two things together, and we're going to change the sign. So whatever this sign is, change it. So that's minus because that's minus. Okay, that's minus because of that. This is opposite. So whatever this is, change it. This was plus, this would be plus, this would be minus. And then I just multiply these two things together. 2 times 1 is 2. And then m squared p to the 4th y z to the 5th. So m squared p to the 4th y z to the 5th. No powers changed. The only thing that could ever happen other than powers changing over here would be if this had been like 3. If this was 3 and this was 2, all of a sudden this is 6. So don't write 2, 3, write 6. But the letters are always going to be different, so just stick the letters together. And then the final piece is right here, and we get the final piece by squaring this object. Anytime you square something, you get a positive, so it's always plus for that last one. Squaring this means to multiply by itself, so 2 times 2 is 4. If that was a 3, this would be a 9. If this was a 10, this would be 100. If this was 1,000, it would be 1,000,000. All right, so whatever it is, you multiply by itself. What you do with the letters, again, is you double the powers. 1 times 2 is 2. 5 times 2 is 10. So make sure that you're careful that you make a distinction between base numbers, and we have a difference between that and powers. So that's how you factor it. Practice the skill, get good at it. That's the only way to be able to master these things.